finally, we'll look at case 3 of comparing different measurements. Case 3, as a reminder, is where we have two different methods, or I guess possibly two different researchers, who are measuring a series of samples that have different concentrations from each other. So sample 1, 2, 3, 4, and 5, maybe we're measuring blood samples, and these are from 5 different individuals. And so we expect them all to have different concentrations. And each of them gives us a concentration. Maybe we're measuring, something in ppm. And method 1 gives us 1.5 for the first one. Method 2 gives us 1.7. And then we have, 5.2 and 4.8, 5.8 and 6.1, 11.2 and 10.5, and I don't know, I'm making these numbers up, 7.7 and 7.6. Right, and so this is the sort of thing that we are comparing here. We've done a bunch of single measurements of different samples, but we have a set of data that we can compare to see if these results agree with each other. Now, how do we do this? So we're still going to use a t-test, but the t-test is computed in a different way. And so what we need to know are the differences. We write these as d sub I. So we'll have a difference for the total number of measurements that we've taken. So to calculate this, we're gonna calculate the difference. For example, for here we'd have negative 0.2, positive 0.4, negative 0.3, positive 0.7, and positive 0.1. Okay, and so then we need to take the mean and standard deviation of those differences. Okay. And when we do these, we need to, remember that we have positive and negative values here, right? So those need to be taken as positive and negative. All right. We won't do this with this actual set of data, but just to kind of show you, this is the set of data that we need. So we calculate d bar and SD, right? The mean of all the differences and the standard deviation of those differences. Once we have that, calculating t-calc is pretty easy. So t-calc is then just equal to the absolute value of the mean of the differences. So that's why we need to remember to keep track of that these have signs, divided by the standard deviation of the differences times the square root of the number of measurements. And then we, as usual, compare to t-table. And the degrees of freedom is equal to our total number of measurements minus 1. So in this case, we'd have 4 degrees of freedom for this particular set of data that we have. You'll get a chance to do this on your homework, even though we're not going to go through this specific example in this video.